This model looks to see if a team should practice defense or offense, and which actually determines success. In this Markov model, there are 28 different states a team can face in any inning. For example, bases loaded with one out is considered a single state. This model is based on the probability of moving from one state to another. For the sake of simplicity, we'll assume a good offense cannot also have a good defense, and vice versa. We will also take pitching out of the equation by assuming both teams have pitching staffs that are equivalent. Now let's look at what makes up the model. You have to create a transition matrix containing all the probabilities moving from one state to another. We will call this T. Then you need to create a matrix containing the expected run values after every possible state. As you can see, the equations go from quite simple to very complicated. Any spreadsheet program can do the calculations seamlessly, so the important part is to understand the two matrices. To determine the values of the probabilities, you need to use variables. The variables are the chances the batter reaches first, second, third, or home during a play, or the chances the batter makes 1, 2, or 3 outs. To determine our variables, we will use last year's Southern Conference Baseball League. The top half will be averaged to make the good offense, and the bottom half will be averaged to make the bad, and the same will go for defense. The only matchup we need to evaluate is a good offense with a bad defense versus a good defense with a bad offense. In MATLAB, you have to create the transition matrix T and the R matrix for both scenarios. And then all you have to use is a very simple calculation. This equation for E gives you another 28 by 1 column matrix. However, we are only interested in the first row of the column because it is equal to the expected runs scored in a single inning. This number times 9 gives you the estimated runs scored in the entire game. As you can see, a bad offense with a good defense actually produces more runs than a good offense with a bad defense.
Fresh Kid P, Fresh Kid T. Oh yeah, we back. Oh, and Zafoon, by the way. Yeah, Jones. Yeah. Chitty Bang. And we pretty much amazing. Can we hear your new song, please? I got you. Hey yo, I once was a kid, all I had was a dream. More money, more problems, when I get it, I'ma pile it up. Now I'm dope, want the bread we can toast. So fresh how we flow, everybody get this down.
Limiting the amount of base runners is the key to this model. A good offense cannot overcome the amount of errors its defense makes. So therefore, defense does increase your chance of winning. However, we decided to test this model by using the extremes of the variables. The extremes we used were a great offense with a terrible defense versus a bad offense with a perfect defense. We were surprised to find that the great offense won by a considerable margin. So maybe you should keep practicing your batting. But just remember, defense wins championships.